This brown dwarf, thought to be in Aquarius, we think is moving towards Pisces and is moving south. We do not think it is a stationary, typical Milky Way galaxy star. We think it's inclined and orbiting our sun, comet-like orbit. It has 7 exoplanets. We have found other stars, larger stars, with 7 or more exoplanets, I believe. This isn't the first one. What makes it special? I'm trying to still figure it out. What's special about this other than it's probably Planet X? There's more than one reason. There's 100 reasons why I would tell you that. The circumstantial evidence is just so, it's so extensive. It's really hard not to consider this our binary twin. So we're going to try to go through the press conference and go through the articles on this new brown dwarf, red dwarf, cold dwarf, dwarf. We're going to...
Okay, guys, my personal position, although there's a lot of people who have been studying this phenomena, most are latching onto a brown dwarf star. I'm not sure if I know anyone that actually is suggesting that there's a primary star which is in fact not a brown dwarf, but in fact a neutron star, a Najm Thaaqib. Yes, I mean, the only reason why I've come to that conclusion, and then we've found evidence to support that, is not only the observable and the observable evidence and the data that we've been studying since this phenomena, but also through light of Quran, I guess, what's revealed in it. And there was always a word about a bright, uh, 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 a piercingly bright star, a star with piercing brightness. And um, I was always looking for that star in the system, because any system that would be approaching us, we would know about through Quran and Sunnah, and it would have been made known to us by our beloved Prophet Muhammad Mustafa sallallahu alaihi wasallam, as simply because something so large would never have been omitted by him, especially if it's going to affect the ummah, humanity. And in this instance, there was mention about a bright white star, a bright star, but not a brown dwarf or a red dwarf, which are both akin to burnt out stars, basically, with very little light of their own that they emit. And because there was this contradiction between the Quran text and what everyone else was looking out for and studying, my, I guess, uh, pursuit for that star gained momentum. Subhanallah. Again, like I said, I mean, there's like all the dreams that have kind of been uh, central to keeping me on track and um, maintaining that momentum to get to the bottom of it and the truth of what is possibly happening. But I mean, again, in this vlog, you'll see this gentleman. There's a lot of things I agree with him, especially about these celestial bodies, perhaps being the celestial bodies that have come into our solar system, and they're not again in the tertiary, in the third outside of our solar system, like NASA has been known to talk. It's their spin, and we've seen that. We've discussed that in many vlogs where different aspects of the solar system are discussed, but it seems they're actually referring to encode the binary system and the characteristics of it. And in this instance, I think they're referring to the binary system again. But what we see over here is actually meant to be a white dwarf star, um, uh, as opposed to a red uh, dwarf star. Because my position is that this would be a white dwarf star. The sun would be next to it, as we've seen, and I've already provided enough evidence to support that hypothesis. Then I believe a brown dwarf star like that is somewhere out here in the outer reaches of our solar system, maybe within the asteroid belt, right? And it also has some celestial bodies around it. Um, Now, these celestial bodies seem to be rotating around their primary star, the neutron star, which is parked next to our sun. But what's more interesting about this particular vlog is a discussion about how they're basically rotating around their star in a 90-degree inclination, which is, subhanAllah, very interesting. We mentioned that the stars come from below the ecliptic, and its north and south magnetic poles are on the horizontal as opposed to the vertical. Why? Is because it's come from below the ecliptic, and it spins in the opposite direction as well. Okay, so they're going like this through our solar system at the moment, whilst the neutron star is also locked in a spin, an orbit with our sun, right? So we're going round in the horizontal orbit around our sun as we do. And this particular star and its celestial bodies are actually going up and over and round, right, in their respective orbits. And this is indicative of what we saw when we saw the the red and the white, the red and the blue lights on both sides of the star, the neutron star that I showed you guys on spaceweather.com, taken by an astronomer on the horizontal planes, and that's the negative and the positive poles, the north and the south poles. On our sun, it's the opposite; it's vertical, right? The north and the south, and then we spin on the horizontal around it. Anyway, I'll let this chap continue. I just had to make that clear so you understood. Again, this gentleman, like I said, his position is based around a brown dwarf star, like most people in this community are researching this phenomena. I think, bar myself, I don't know anyone else, to be honest with you, other than another researcher who also believes that it's a neutron star that's come into our solar system. And again, I've maintained that it's a binary system that's merged with our solar system, making it a trinary system if you include our own solar system to that. The binary system, simply because there's a brown dwarf star and a neutron star, and they both um, have come in together simply because the brown dwarf star actually orbits the neutron star. Yeah, and the neutron star and our sun orbit one another. If all of that makes sense.
I'm going to try to figure out what the heck is going on. Now, Astro Traveler, his channel, detected and used the recent WISE Sky Survey from 2010, identified a huge infrared emitting object in Aquarius. We made a video about his findings, and apparently they had named that dwarf in Aquarius, but nobody had ever really said much about it. But they've known for years it had exoplanets. So why the announcement today? What happened this week? And when you look at the declinations of these things, it's like a 90-degree declination. That's the angle at which they orbit their parent star. When you look at this simulation, it doesn't look like there's any declination. It looks like everything's rotating on a flat disk. And so you have to wonder why they would put such accurate declinations with very low margins of errors, or you can call it an inclination.
Here you go, guys. The inclinations here, which is, yeah, it's, like you said, it's 90 degrees inclination of these celestial bodies. Yet on the model, just as you saw previously right now, they were rotating. The model's a false one, because this information is specifically about that particular system that they have apparently found 40 light years away from here, right? And the inclination of the celestial bodies orbiting that star has been put down as 90 degrees. Yet we see them rotating around their parent star horizontally, just like we are around our sun. There's certainly a huge error in that model, and why would they do that? Again, this researcher and I may agree with him, is that they've deliberately done that, but they're actually referring to the binary system that's entered our solar system, which is accompanying the neutron star, and that's hence why the 90 degrees inclination of that system, because it's come from the ecliptic, and everything about it is opposite to our solar system, even its rotation.
And then show a simulation that has these things orbiting column towards the right side of your table, and you can see they're almost all at 90 degrees. And here are the other specs on mass, size, orbital periods. So they've been looking at these things for a while. In the press conference, they act like they just barely got a glimpse. So, but then you go to other simulations, and it looks like a spiral. It looks like they're not in a flat disk orbit, that they're in a spiral orbit chasing after a brown dwarf.
So every time he says brown dwarf, I say neutron star, a bright white star, as opposed to a burnt out one. Yeah, that's the only thing I guess here that I disagree with this gentleman on.
This is really amazing how they went about announcing this. There's something big about this announcement, but during the interviews, nobody could really pinpoint what was big about it. They act like Hubble is incapable of determining the atmospheres on these exoplanets. And Hubble has one of the most advanced spectroscopy instruments ever put up into space. Articles are everywhere about Hubble's ability to peer and use light refraction and light reflection, light absorption to tell us what's not in the atmosphere. And they set this thing up to look for life, signs of life. So this thing is capable of finding oxygen, water, ice, methane that are in some of these Earth-like bodies. I went through and spent 2 hours reading up on the spectrograph and the spectroscopy instruments on Hubble. And indeed, they are singing the praises of those instruments. But then why in a press conference do they downplay what Hubble's role has been? You could look at all the literature on Hubble's ability to peer into the atmospheres of planets and measure infrared light's response, visible light response, ultraviolet light response, and possibly even lower wavelength. So Hubble's had the ability to detect what was in the atmospheres of objects further away than this. And it has, and we'll show you. But when you could look at a star 140 light years away and look at the planet and say that the planet orbiting the star has a dust cloud of ice and water from 140 light years, then what's the problem at a 40 light year distance, if you even believe that? We could even do this from Earth. These are just asteroids, people. These are asteroids in the asteroid belt using spectroscopy on Earth, Hawaii, Chile. All of these special new telescopes that have gone up that you don't even hear about are able to use light wavelengths and learn a lot about everything that's around us. And there's even categorized the contents of these asteroids in a catalog. And those contents were determined how? Through spectroscopy. And there are articles about how Hubble has found this and that. These telescopes have found many things, this and that, out to 140 light years and beyond. So, and with great specificity. And in fact, the spectroscopies is like one of the most valuable tools that astronomers use, period. And they've been using it. They've been using it from ground-based. They've been using it on Hubble. They've been using it on Spitzer, even has a spectroscopy, more narrow ranges. So even Kepler. And Kepler's discovered so many exoplanets, it's not even funny. So with 1,000 exoplanets in the possible habitable zone, what makes these three in the system of 7 so special? And the answer to that question is nobody knows. But here's an actual photograph of Hubble taking a picture of what? A brown dwarf, and using a star's light to see anything that moves in front of the star. And Hubble has picked out a planet, and it has mapped its orbit. It can tell you how long it takes to orbit the star. It can tell you the mass of this thing. I think this is Fomalhaut B, and they took pictures of this star a couple years apart and saw that there's an object in front that has moved, and they were able to map it and extrapolate its orbit, its size. They tell you that there's even a dust cloud associated with it. How can they do that from so far away? The other thing is there are exoplanets that are closer. There are at least 24 exoplanets in the habitable zone that are half this distance. So why aren't we worried about those guys? Why it's something 40 light years away? Why make such a big deal? Well, look at the next to last column. That's the inclination. So are they saying that these exoplanets are in a polar orbit? Is that what they're saying? Nobody's really advertised that, and some of the simulations show them in a flat disc-like orbit with almost no inclination. But anyway, here's some remarks on the press conference.
At the announcement of the first exoplanet ever discovered and announced in 1995. And since then, we've found thousands of those. A little bit under 5,000 the last time I checked. Dozens of them are in the habitable zone. Dozens of them are in the habitable zone. Dozens of them are in the habitable zone.
User J Jams, who asks, what is the total amount of possibly habitable planets we have found, including these Trappist discoveries?
Okay, the total number of habitable planets, believe it or not, is unknown. And it depends on who you ask and how you count them. We would say that there are, let's say, a few dozen exoplanets that you might consider habitable, but the bottom line is that many of them may be a bit too hot or a bit too big. We really have to wait until we can see the atmospheres to know how hot or cold the planets really are. And that's why the Trappist planets are so relevant, because they actually, unlike a lot of the other habitable zone planets, we can actually assess them in the near future.
Wonderful. All right, the next question here comes from Scott, who asks, any confirmation of water on the planetary bodies?
Yeah, I can handle that one. There's has not been any confirmation of water on these planetary bodies, and it'll take a lot of observations with Hubble or in the future with Webb to probe the atmospheres and see if we can detect water on these planets.
But I think it's fair to add that people are looking.
Yes, we are certainly looking. And it'll take a lot of observations with Hubble.
Asks, will this be one of the first observations for JWST, and how much can we learn about TRAPPIST, E, F, and G until that mission launches?
I can take that one too. You know, a lot of folks, since learning about the system, have thought about observing it with JWST, and I am fairly certain that Cycle 1 will see some observations of almost all of the planets in the system.
I was wondering, how many years do you think it might take to have a real good handle on the atmospheres of these exoplanets? And I have a follow-up question.
Yeah, so we could actually make a substantial amount of progress in the next, after the launch of JWST, the next sort of 5 years range. So starting with Hubble and then moving into JWST to continue the exploration of these atmospheres, we could see results, in the early 2020s.
It's from Miles O'Brien here on Twitter, who asks, what sort of instrument could be used to answer the question of whether these planets harbor life? could Webb do it?
Sure. So Webb has a suite of instruments that cover, wavelengths from sort of the near infrared all the way through farther into the infrared spectrum. But in particular, it has a lot of very powerful spectrographs aboard. So this is going to allow us to do this transmission spectroscopy technique that I talked about earlier. And it covers the right wavelength range where we can start to detect molecules like water, methane, ozone, and oxygen. So we can start to do a lot of what Sarah had suggested in trying to determine habitability and also the potential of it harboring life.
And I just want to add one thing, and to Miles and everyone out there, is we really try to emphasize we have the capability to find signs of life elsewhere, but nature has to deliver. And because it's all so new to us, these red dwarf stars, we don't totally know what's out there. So if nature has made life ubiquitous, and there are lots of atmospheres without clouds, substantial enough accumulation of gases, we'll have no trouble finding it at all. But if it's the opposite, then it may be a while. But I did want to add one more point that we hadn't covered yet, that we have the TESS mission upcoming. We have other ground-based searches. So Trappist 1, we're just here as the first. It's the most exciting one so far, but we hope to have many more of these and lots of chances to find signs of life in the future.
Question comes from Twitter user Aku, who asks, any estimations on how old these discovered exoplanets are?
Yeah, the age of the star and the system itself is poorly constrained. We know it's not very young, it doesn't show signs of youngness, so it's at least 500 million years old. But we can't say more because these ultra-cool dwarf stars, they evolve super slowly. Their lifetime is 1,000 times larger than for a sun-like stars. So we don't see them evolving, so we can't constrain their ages.
Great. This next question comes from Twitter user Ross Butler, who asks, is the TRAPPIST-1 system the closest to us with planets in the habitable zone?
No. In fact, the closest is Proxima Centauri, which has a planet which was detected by radial velocity, so by another method, which doesn't tell us the size nor the mass. So we don't know if it's a rocky planet, but it is in the habitable zone, clearly.
Why this finding is so exciting for you personally, and we're going to start with Nicole and then work our way to Thomas.
Yeah, so this finding is really exciting for me because this is a great opportunity to study Earth-sized planets' atmospheres in great detail. This is a great opportunity to study Earth-sized planets' atmospheres in great detail. We know that we can get good signal. We know that we can get good signal to noise ratios, and we can start to begin this journey in trying to understand what the air is like around rocky planets outside of our solar system.
Well, I'll give two favorite reasons. One is when I and others started in exoplanets 20 years ago, our peers all dismissed the work as just stamp collecting. We'd never look at their atmospheres, we'd never be able to do this, we'd never be able to do that. So the fact that we're here today with 7 planets, and we know we can study their atmospheres in the future, is truly tremendous. The other point I want to make is that we're really excited because we all see ourselves here as just, we're the group of people, we meaning us and all of our colleagues, as the pioneers. This is a search that will go on for many generations. And just the fact that we're this close now to finding so many habitable worlds is really exciting.
Yeah, so for me, it's more of a very kind of a personal experience because I've been worked on Spitzer since 2002, and the ability to be able to do these observations, we had to do a fair amount of engineering work, and At the beginning, it wasn't clear necessarily that we would be able to achieve the precisions we need to do up science like this. So it's very gratifying that all our hard work, myself, my colleagues at the Spitzer Science Center, JPL and Lockheed Martin, the engineers there, we're able to pull it off, and we're able to be able to give great data to scientists and get great results out. So I'm very happy about this.
Then I switched to astronomy because it was the beginning of the exoplanet adventure. We were really beginning to detect planets outside the solar system. And it was clear that within a few decades, we would be not detecting giant planets which were unsuitable for life, but planets that could host life, that we could study. So I've already been devoting my time in science to this goal. And then we're getting nearly there with this result. It's a very good satisfaction for me. We're getting nearly there with this result. It's a very good satisfaction for me.
To me, looking from the point of view of NASA science program, it's exciting because of course it's a leap forward, but it goes in parallel to the other leaps we're taking right now. Look at what's happening at Mars, where we're really looking at the complex chemistry that's happening there. Look at the recognition that Mars actually is a place where there not only used to be water, but there's water today, abundant water. In parallel to that, the recognition that we can now have the technology ability of going to Europa and actually looking at that system, which is in its own right really an exciting system, because there's an ocean world there that hits the rock at the bottom in a really unexpected place in a site. There's many other places like that. And then on the theory side, we already heard that the really understanding of the biology of life. There's a tremendous amount of progress. So together, these areas really create kind of a crescendo towards that, really answering that question that has been on our minds for so long. This is the right time to ask that question. It is the right time to have this discovery right now. The right time to ask that question. It is the right time to have this discovery right now.
Why they went through this hoopla and have all this stuff out on Trappist, and the Wikipedia is already completed, 100% completed. They have websites for Trappist 1. They have an exoplanet section now, and it makes you wonder what is the big deal. And the only thing that I could tie together is that they do find water. They know that planet that takes 12 days to go around on an orbit is probably the one that they need to look at. But here in front of your face, these are things that Hubble has been able to discover at 96 light years away, many, many times further, by looking at the atmospheres of certain galaxies, stars, and planets. So, this is a rolling disclosure, in my opinion. They're getting ready to release something big.